Hi guys, Mr. Sonnenberg here. Today we're going to be talking about testing of toxicity. So we're going to talk about LD50. That's going to stand for legal dose 50 and or 50%. So this is for Science 9 students studying environmental chemistry, topic 4 in your textbook for study references, and the specific outcome corresponding to the information, or what I want you to know at the end of the screencast is that you can understand and are able to interpret information on how living things are affected both locally and globally by chemicals released here or in other parts of the world. So first let's discuss what this LD50 means. So LD50 was actually a way that scientists used to measure toxins and the amount of toxins. And so they used to measure it in LD50 amount. And LD is actually going to stand for lethal dose, whereas the 50 is going to represent 50% of the subject group that is going to die if they're given a specified amount all at once. So if you give them a certain amount, all at once, 50% of that population will die, or that subject group. So that's what it's saying. So it's going to be measured in parts per million, okay, this lethal dose. So LD50 measured in parts per million, or what we would know as milligrams per kilogram, okay. And originally this research was actually done on rats, which is going to lead us into its controversial nature. So classic LD50 tests were very controversial in many countries, and since have been restricted, regulated, or outlawed altogether. So some organizations really like to tell how cruel the practice really is, because they are testing on rats, and so animal cruelty and such. So really we don't see LD 50 experiments. We rarely see them performed anymore, and a lot of the information uh, that we get now comes from more modern techniques. And because the LD50 really didn't give us as much toxicological information as we used to get, or as we do now, for modern techniques. So the most lethal dose, though, of this LD50 actually comes from a bacterium, and you just take a look. It's right here. Okay, so the actual bacteria itself, though, is the most toxic. Is we're gonna call it. See if I can spell it right. Um, Toxin A. So botulinum toxin A, and that's going to come from Clostridium botulinum. Okay, and that's a bacterium right here. So what that is a bacterium. Okay, so that's the most lethal, that's the most dangerous, and we actually find that in some of the common consumer foods. Okay, but it can be destroyed by high temperatures or acidity, so we can actually control it and manage it, but having the information on it, on this toxin and such, or lethal poison, is very important. It's going to help us out a great deal. So moving on. So what is acceptable risk? So what we're at risk to, and we're always exposed to different toxins. There's a lot of natural toxins as well that we even use in our body. Animals, plants use it, but we always think of them as very bad. But what is acceptable risk? Like, at what point are we at risk of being of these harmful effects affecting us? So there's been some very strict guidelines that are implemented to testing programs, because they want to prevent these fatal doses from being consumed. They want to from being issued and used in an improper way. So there's a lot of helpful tips. There's very strict guidelines before these products can actually get administered, or actually produced and sent off to the public. But then there's government agencies and legislators that really try to push, because sometimes there's new medications possibly, and they try to fast track these drugs and substances, and then because they can actually help people. So maybe they can relieve some form of discomfort or pain, and so they fast track it. And so what happens is, us humans, we get a lot of our information about fatal dose from accidental exposure case studies, and we get a ton of those because sometimes there's this fast tracking. But what we're going to look at now is actually one drug that kind of went wrong. Testing was done on rats, but the rats, we would assume that the rats we could consume much more than the rats could withstand, but it was actually an opposite effect. So it was called thalidomide, and thalidomide was originally developed as a sleeping pill, but its use in the 1950s and 60s was also used by pregnant women. And what they did was they wanted to treat morning sickness symptoms and morning sickness, and it actually eventually led to thousands of birth defects. And we can actually see in this picture down here some of the birth defects that we would see. But what they did was they did a close inspection of this drug, and they actually found that if you gave a dose of 4,000 parts per million to a rat, what they thought would be expected, that because we're so much larger than a rat that we would withstand much more than that. But what was happening was in the pregnant women, the fetus was affected by a dose as small as 0.5 parts per million if it was taken at the wrong time during developmental stage. So then what we see all of these like right here, we see all of these birth defects, like that limb right there and the foot and such. We see these birth defects that were occurring because the dosage actually affected the fetus at such a small amount. Now remember, when you're dealing with this, when you're dealing with LD50, the lower the amount, the more toxic the substance. So if you get an LD50 in this case, the obviously this amount at 0.5, that's the most toxic. Even though it's a smaller number, it means it's the most toxic. And this is less toxic. Okay? So the more toxic, that means that with that dose of 0.5, 50% of that population, if it was consumed all at once, will die. Which, that's why we see a lot of these birth defects and such when thalidomide was used. But after further studies, then it was removed. Now, when we want to evaluate the risk of these LD50 doses, Rachel Carson, and remember her from earlier studies when we discussed the DDT issue, she created an enormous publicity for the human use and abuse of toxic chemicals. So, but the thing is, she also talked about is we often overlook the fact that there are not just produced toxins, but there's also natural toxins. And plants and animals use these toxins all the time, and in terms of further survival. And they use them as helpful tools to survive and necessary components. So, what risk do we take, and which are acceptable to us? So to receive a dose, basically if I was to give a dose to a mouse, okay, or to mice, and of a particular substance, we as humans though can consume 70 cups of that substance all at once in one sitting though. So if I take it and I just take 70 cups all at once in that same sitting, then it will affect me, right? So this gives us the ability to look at risk and how much can we consume, or what the toxic effects, what are they going to have on us? Are they acute? Are they chronic toxicity? How much of this can I have before it really affects me? And then the second thing is it can vary. So this LD50, it can vary from animal to animal. Like we can take a rat, we can take some mice, or rats and mice, and we can actually see that it's going to affect both those very differently, even though so they're similar in size and they're similar animals, it's going to affect them a lot different. So we can when we're evaluating the risk, okay, we have to know that it's going to vary from animal to animal. And then also it's going to depend on the type of exposure you have. Are you going to ingest it, so you can eat it or drink it? Are you going to inhale it, which is through breathing, or are you going to come in contact to it with your skin? Okay, so those are all going to, when evaluating risk, those are three things that we need to be aware of. Now, the last thing is, which is more toxic? Like I said, the lower the amount, the more toxic the effects are. So I said the botulinum toxin A is the most lethal, the most deadly, okay, or most toxic. poison or toxin. So if we look here, I'm just going to get you to take a few seconds. I want you to try to put these in order from most toxic to least toxic. Okay, so from most, okay, to least, and that's toxic. Okay, I want you to try this out. Alright, so what we have here is the most toxic is going to be this, because it's the smallest dose. Okay, so it's the smallest, so it is the most toxic. So that's the botulinum toxin A. The smaller the amount in parts per million, the more toxic it is. This is going to be second, okay, 0.03 parts per million, and then this is going to be the least toxic with 40 parts per million. Okay, so when we're actually reading that, or when we're looking at this, if I was to look at a scale, then I'm going to look and I'm going to say, okay, if I see a chart with this information, I'm going to look at the smallest value. I'm going to know that that is the most toxic. And the highest value, which in this case would be 40 parts per million, is going to be the least toxic. Okay, so lethal dose, LD50, it's lethal dose, 50% of that substance will kill the subject group if it's consumed in one sitting all at once. Anyways, that's LD50, and those are some toxic effects, guys. Hope this has helped. Bring your questions to class. Hopefully you take some notes on this stuff, and hopefully this has helped. Okay, thanks for tuning in. Bye.